Morning students, myself Dr. Yogesh Kumar. Here just want to represent the voltage and the current source to get the knowledge of the voltage and the current source. Now what is the basic idea? Before going to the deep knowledge, we have to idea that is the basic knowledge of the network. Now what is the source? We are considering the voltage source and the current source. The basic is what is the source? Source is nothing but what? That provides the electric energy to any network or the circuit. On that basis, any appliances can work. So source is a device that converts mechanical, chemical, thermal or some other form of energy into the electrical energy. In other words, the source is an active network element meant for generating electric energy. So there are the two type of sources. Generally we have heard about the voltage source and the current sources. In terms of voltage sources, that the forcing element is the voltage, and in terms of current sources, the forcing element is the currents. Now let's look at figure. First, parental is the source. It can divide into two parts. One is the voltage source, another is the current source. Now voltage source is again divided into two parts, ideal voltage sources and the practical voltage sources. Current is again divided into two parts, ideal current source and the practical current source. Let's say first voltage source. Voltage source is nothing but in which it is a two terminal device, whose voltage at any instant is the time is constant. It is independent of any other current drawn from any circuit. Such voltage is called the ideal voltage source, and it has the zero internal resistance. For practically it is not possible, any ideal source cannot be obtained. So we are using the always practical voltage source. It is having the internal resistance and some voltage drop across this internal resistance. So the smaller is the internal resistance of the source, the more closer it's a ideal source. Now here you can see the symbolic representation of the ideal and practical source. This is the ideal voltage source and this is the practical source. Generally we have seen such type of plus minus symbol. Now let's say graph between the ideal and practical voltage source. First look the ideal voltage source. If having the ideal voltage source, definitely the voltage is almost constant throughout the entire circuit. Okay, if we are taking the practical voltage source, then definitely we have to take the consider internal resistance. So definitely some voltage drop across this internal resistance. So definitely we will not get the constant output voltage. So this dotted line is showing the ideal, but this line shows the practical source. Generally we are getting the such type of output only. Now what is the current source? In similar way that I've defined the voltage source, current source is also in two parts, ideal current source and the practical source. Ideal source is a two terminal circuit which supplies same current any load resistance connected across its terminal, and practical current source is presented an ideal current source connected to the resistance in parallel. Means in ideal current source there is no resistance connected in the parallel, but practical current source we have to apply a resistance in the parallel. Here is again symbolic representation of the current source. One is the ideal, one is the practical source. And if you want to make a graph, just like same as the voltage graph, we are getting the constant voltage in the ideal current source. If you're going for the practical, as already I told you, we have to put a parallel resistance across this current source. So we are getting some voltage drop here. So we are not getting the voltage same throughout the circuit, so we some voltage drop over there. Let's have a parental, a figure that is a total energy source, again divided into two parts. One is a direct source, another alternating source. We have to consider only direct source. Direct source is nothing but the independent voltage source and the independent voltage current source. Again we have to take the consider the dependent voltage and current source. It is divided into four parts. There is the voltage control voltage source, voltage control current source, and third one is the current control voltage source and the current control current source. Let's have the what is the source. I will already told you there are two type of direct source, another is the indirect source. Direct source is what? The direct and voltage source, the direct source, whatever we heard about the voltage and current source, that is only the direct source. And in that again divided into independent voltage and current source. Independent source is not dependent on any other quantity. It is independent all other the parameters. There are two terminal device, another constant value. The strength of voltage and current are not changed by any variation in the connected in the network. That is called the independent voltage and the current source. And dependent is the opposite of the independent. They are change, they are not fixed, they are depends upon the voltage and current value that are flowing in the entire network. When the strength of voltage current changes in the source for any change in the connected network, they are called the dependent sources. This is opposite to the independent. Generally they are shown in the diamond shape. Now dependent source can further divide into, as told you, first voltage control voltage source. That you can see is the voltage control voltage source. These are both the dependent on each other, so we can write VAB is proportional to VCD, or you can say the VAB is equal to K VCD. K is nothing but one constant. Similar way, voltage control current source is what? This is the voltage control, this is the current source, both are dependent, so this current source is proportional to VCD. If you make a equal, then we have to put one constant, that is eta. Eta is nothing but transconductance. It is a reciprocal of resistance, and its unit is. Now third type is the source, that is the current control voltage source. In this you can say the current control and it is the voltage control. Both are independent on each other, so we can write this VAB voltage source is dependent on the current source, that is the ICD. If you make it equal, then we have to put a constant, that is the R. And last is the current control current source. It is both having the current sources IAB, let's say ICD, both are dependent on each other, so IAB is proportional to ICD. We have to make equal, so we have to put constant, that let's have as a beta constant.